Maybe Bharat, you can also start the live, no? It's 1 minute.
Wonderful. I think we are going live. So if you're watching this right now live on LinkedIn or YouTube, very excited to have you. We're just going to wait another minute or so to get all started. We're just getting all set up here with the Battery MBA cohort who are joining us here as well, live as well in the back end. It's very good to have you here, Eric and everyone. Good to see you. Today is a bit of a special session, so very excited for everyone here. And of course, also everyone watching this live on LinkedIn, YouTube, big welcome to you. Thanks for joining us for that as well. And hopefully you can engage with us. Keep your questions coming in the comment section, either on LinkedIn or YouTube. Of course, we would love to hear from you as well. Again, this is an open platform, so very excited to have you all with us. So we're here today with the 11th roundtable of Battery MBA. Time really flies, so it's been quite a few cohorts. So really excited to have you back with us. We're doing this roundtables as part of the Battery MBA program for the final week, where we're kind of really having a bit of a wider look at the topic of perspectives on the future of batteries. We take a bit of a thinking head on and think about what might be coming. And again, this is also together with Battery Associates, who's running the Battery MBA program. So if we just go to the next slide, please. It's just a quick welcome from me for our speakers before we're going to introduce them all one by one together with Shada, who's co-moderating the panel with me. But for now, we're not going to go in much depth of our speakers because we have time for that later. But we already have Dr. Aaron Wade with us, who's the head of battery costs at CRU Group. We also have Dr. Jennifer Channell with us, who's commercial and partnerships lead at Anaphite. We also have Rob Johnson with us, who's the former global purchasing director at Jaguar Land Rover. So I think a really exciting panel, some great perspectives. So really excited to have them all with us today. Really appreciate for you to be here. But for now, let's do a quick intro who we are as Battery Associates as well as the Battery MBA. With this, I want to pass on to Melanie to introduce that. Thank you.
Hello, everyone. I hope you're all having a great summer. As a quick introduction to Battery Associates, our mission is to create a sustainable world through the power of people and battery innovation. We do this through three main arms: Battery Pro, which focuses on consulting and customized training to support businesses in their transition to a battery-powered world. Also through Battery Lab, which is our innovation hub, where we aim to bring about affordable and innovative battery solutions. And finally, through Battery EDU, which is our education and training hub. Here we aim to train a diverse and global battery workforce through our training programs, including our flagship Battery MBA program. For those who don't know about the Battery MBA, it's a CPD accredited 12-week-long online program that we offer 3 times a year. We have more than 520 alumni from over 50 countries, featuring more than 30% female participants. Professionals who participate in our program come from leading organizations in different stages across the battery value chain, such as Tesla, Li-Cycle, PowerCo, Jaguar Land Rover, Esvolt, BASF, prominent in universities worldwide, and many others. The program is meticulously structured to accommodate full-time professionals with a manageable time investment of 2 to 3 hours per week. If you're keen on joining this program, we invite you to apply for our upcoming cohort starting in September, which is on the next slide, using the link seen here on the screen. Additionally, we're pleased to offer a range of scholarships designed to facilitate inclusion of individuals from groups that are traditionally underrepresented in the battery sector. If you have any questions, feel free to contact us at info@battery.mba. We're also excited to share that our 5th annual event, Battery Day 2024, is upcoming and scheduled for the 26th of September. This is a full-day online event featuring leaders from various industries across the value chain and showcases both panels and deep dives on pressing battery developments. We invite you to register using the QR code here or the link provided. Now I'm going to turn it back over to Simon.
Thank you so much, Melanie. And that's also something really exciting we have seen now with our community meetups. And we have been bringing together a range of Battery MBA alumni as well as ambassadors and partners of Battery Associates over the past few months. So that's something really exciting. You can see here all the way from China to the UK, as well as in Germany, as well in the US. And we actually have two already planned again, or three actually planned next, which are in October in India, as well as in the US, and then also in Germany again in November, and we're doing this as part of the US Battery Show, India Battery Show, and the Future Battery Forum in Berlin. So that's something we're really excited for. And I think really, speaking volumes now that we have more than 500 participants and alumni, and of course, this current cohort being part of that very, very soon. So I think that's just a really exciting involvement we have seen to also go more into the physical world, as we also spend a lot of time together online in these programs, but we're also really keen to bring you together in person. And just as a quick note for all the alumni watching, please find us in any of the events. We have some very special tokens of appreciation and new merch. So, I would love to share this with you as well. So please find us in any of the events we're attending. As you know, you can find us through the emails and the event calendar we're sharing that way. Great, and I think we will go through this in a moment. So for now, let's please go on the next slide, introducing our speakers of today. And Shada, with this, I would like to introduce our first speaker. Thank you.
Yeah, thank you very much. Good morning, good afternoon, good evening, everyone. Welcome to today's panel discussion on the future of batteries and energy storage. We're really delighted to have you today and delighted to have an exceptional lineup of experts with us today. And first, Aaron Wade joining us. Aaron leads CRU's battery cost modeling team, specializing in forecasting the production cost of both current and next generation battery technologies. His work focuses on understanding how and when new technologies will impact the battery market. Prior to joining CRU, Aaron earned his PhD in lithium-ion battery degradation from the Faraday Institution at University College London, during which he also completed a part-time internship at Exawatt. Additionally, Aaron serves as the project director for Battery Pop, an online networking platform designed to connect and engage the global battery community. And I hand over to Simon for Jennifer.
Thanks so much. And yeah, it was Jennifer, Dr. Jennifer Channell. She's the commercial and partnerships lead for Anaphite Limited, where she leads the commercial and marketing functions to bring Anaphite's dry battery electrode process technology to market. Jennifer has been instrumental in growing the UK battery industry through her role as innovation lead for the UK government's Faraday Battery Challenge. Jennifer is also project director for Europe for the Volta Foundation, a not-for-profit dedicated to advancing the global battery ecosystem through community. Jennifer has a PhD in chemistry, is a battery ambassador for Battery Associates, and is a professional member of the Royal Society of Chemistry and IOM3. With this to Rob. Thanks, Shada.
So last but not least, Rob Johnson joining us today. Rob has a distinguished career as an executive in global automotive supply chain. Most recently, he served as a global purchasing director at Jaguar Land Rover, where he was responsible for procurement related to battery propulsion, among other commodities. Earlier in his career, he was a vice president of purchasing at Toyota Motor Europe. Currently, Rob holds the position of honorary professor in purchasing and supply chain management at Nottingham University Business School. Additionally, he serves as director of Deepfarm Limited, a technology spin-off from Cambridge University, and as an advisor to Invoice Limited, where he specializes in helping battery and automotive companies enhance operational and supply chain sustainability.
Brilliant. Thanks so much, Shada. And let's go right into it. And maybe we can also remove the slides for now to kind of make us a bit bigger here and start with Aaron for the first question. Would love to have your take on, especially on the topic of cost. I know it's something very passionate about. People who know you from LinkedIn, etc. I know you're also quite active on that topic. It would be really great if you could share a bit about the topic of, what are biggest drivers of battery cost today, what you might expect for the near future, and also maybe how you see maybe the balance between cost reduction and also technological innovation shaping the future.
Yeah, sounds good. Great to be here. Thanks for the invite. And yeah, love talking about battery costs, so happy to do that. So if we look at the cost of lithium-ion batteries today, the biggest single cost component is really in the cathode active material. So this can make between 30 to 50% of the total cost to produce a cell, and that obviously depends on the chemistry and the type of cell and a whole range of factors. And then moving to, let's say if we're NMC 111, moving up in nickel content, where we increase our energy density can help decrease the cost. And we look at within the CAM and within the cathode active material, the biggest single cost component is really the lithium price. We saw back in 2021, 2022, the lithium price really spiked and got very expensive. So lithium was sitting at about $9 a kilogram before, went up to about $70, $80 a kilogram during that period. And now we're on the way back down, and we've come all the way back down to about $15, $20 a kilogram for lithium carbonate or hydroxide. So during that time, we've seen a huge spike in lithium price, and therefore the cost to make CAM and then the cost to make our batteries really increased. And then now we're on the other end of that. And this is why we're seeing very low pricing at the minute, in part, is because the lithium price is very, very low, and that's driving these low cost to produce cells. And then if we look regionally, there are big discrepancies between different regions as to how much it might cost to manufacture a cell. Chinese companies based in China have the lowest production cost of all. There are several reasons for this. One really big one is because of vertical integration. So Chinese companies have big ownership in mines, cathode plants, anode plants, and this helps them get those cheap raw materials, that cheap lithium, which helps that vertical integration. But the engineers in these factories have really optimized the production process. And one really good example of this is in the yield step. So we see Chinese factories are operating between 95 to 97% yield, so really throwing away not very much of their materials, where we see factories in the rest of the world during the ramp-up phase, be it kind of 40, 50, 60%, and then struggling to get up to that 90, 95% level. So not only can Chinese companies procure their materials cheaper, but they also waste less of it, so therefore more ends up in the final batteries and then drives those costs down. And then I guess the final reason why Chinese companies have these low costs is because of labor requirements, looking at fewer workers due to optimized production, as well as a lower wage that we pay our workers over in China. So therefore these production costs for Chinese companies are much lower, which is keeping the cost to produce very low at the minute. So I guess to wrap up that section, low material price on the lithium side is helping low production costs, and then optimized factory performance, especially in Chinese companies, keeps these costs low. And then I guess if we look to the future and where things might go, there's really two ways to reduce cost. One is to get cheaper raw materials, and one is to increase the performance of your materials. And then on the raw material price, these can only come down so low. So if we look at what happened in the solar industry, which is a very analogous industry to the battery industry, we saw for a long time that costs of silicon fell and fell and fell and fell. And then it gets to a point where they can't fall any further. And then in solar, you have to increase efficiency. In batteries, we look to increase performance, typically energy density. So this might be moving from LFP to LMFP with kind of limited increases in material costs, but good energy density gains, or potentially by doing step change innovations like lithium metal or solid state or something like that. And then finally, the other option is substitution. So instead of doing a lithium-ion battery, we could do something like a sodium-ion battery with inherently cheaper raw materials in theory, which offsets that lower performance. So I guess overall, lithium-ion battery costs are pretty low at the minute, driven really by that low lithium price. But we see that technology innovation, maybe LMFP, maybe sodium-ion, potentially lithium metal or silicon anode further out, can help drive these costs even lower in the future.
Fantastic. Thanks so much for sharing. And I think we might have a bit of more debate because I think there's a lot of factors, right? You already touched on overcapacity and all these other kind of also interesting developments regionally as well. But yeah, maybe just a quick also note for all the people watching this live right now on LinkedIn and YouTube, etc. Before we're going to ask some more questions, feel free to also put your questions in the chat because this is really your chance. The first 45 minutes is public to you, so we can ask your questions. So please make sure you add your questions on LinkedIn and YouTube. But with this, I want to pass on to Shada for the next question.
Thank you very much. That discussion was really interesting about the strategy to reduce the cost of lithium-ion batteries. Now, my question will be for Jennifer. So, as you know, Jennifer works at Anaphite, and they develop dry electrode manufacturing technologies. Jennifer, since you been developing cathode powders for producing dry coated electrodes, what are the key advantages that dry technology provide us in terms of cost or manufacturing, and as well as, can you also mention the challenges in dry manufacturing and scaling up this technology with respect to, of course, the traditional wet coating technologies? Thank you very much.
Yeah, of course, happy to. I mean, one of the big benefits that dry coating offers speaks a lot to what Aaron was talking about with respect to cost. So cost saving is a massive benefit of dry coating, and the other major benefit is sustainability or compliance. So speaking first to cost, so Aaron already talked about kind of materials hitting their kind of price floor. So another way to reduce the cost of batteries is to address the processing cost. So what dry coating aims to do is to remove the massive long drying ovens that you would find in a gigafactory that's typically used to remove the solvent from the slurry casting process. So you're getting rid of CapEx costs, but also OpEx costs, because you don't need to fund all the energy that's required to power these ovens. And it's about 30% of the battery production process. 30% of the energy demand comes from the drying ovens. So then the other aspect is kind of sustainability and compliance. So obviously, if you're getting rid of the big long drying ovens, you don't need as much energy to power your gigafactory. So if you're in an area where you don't have access to clean energy, then you're massively reducing the kind of carbon footprint of your battery. And then also there's the issue of removing solvent as well. So not needing to do the coating process using a toxic solvent such as NMP means that you can improve the sustainability of your battery as well. But there are still some issues with this. So at the moment, for a cathode, the typical binder that you would use in a slurry coating process is PVDF. And for a dry coating process, most of the industry is working with a fibrillating binder called PTFE, which both of which are hard to recycle. They're often referred to as PFAs or PFAS. And PTFE is just as difficult, if not a bit more difficult to deal with. So that's a challenge that the industry's got to work with. How can they improve the design for recyclability using perhaps binders that don't contain PFAS? And thinking about that kind of longevity perspective. Other issues in terms of scalability, again, coming back to the binder aspect. So if you're dry mixing the materials at ton scale using a binder which fibrillates under heating and friction, then it can be very difficult to scale this up, and you get a big sticky mess. So finding solutions to that challenge are quite critical. There's also issues with safety. So at the moment, the kind of state-of-the-art wet coating slurries, for example, electrodes would contain advanced carbons like a carbon nanotube. If you want to use that in a dry coating process, if you were to put that into a dry mixing situation, you're basically putting asbestos in a blender. There's a severe process inhalation risk. So finding novel ways to introduce the high aspect ratio carbons, which give you that advanced performance, are really critical. Aaron also spoke to the point about getting the most out of your materials and improving performance. So we don't want to find ourselves in a situation where we're having to reduce the performance of our electrodes just to access this kind of cost benefit. We also want to make sure that we're making the most of those expensive materials. So finding ways to increase the percentage of active material, reduce the amount of inactives in there, and get the best performing electrode is really what we're trying to do. And at Anaphite, these are the challenges that that we solve with our dry coating precursor process.
Thank you very much, Jennifer. Yeah, it's really interesting to know, yeah, especially the issues around binder selection. Probably it is really limited choice for the dry coating for the moment. And scale up and safety would be two other challenges of dry manufacturing. Yeah, I would like to remind again to all the people listening to us today, please send us your questions on LinkedIn or YouTube, and we will address them during our conversation today. So I think now we can continue with Simon for the next question to Rob.
Absolutely, and great to see people like Sonu and Jay and others on LinkedIn saying they're really enjoying the conversation, introducing themselves. So yeah, looking forward to your questions coming in there as well. Yes, now I'd like to come to Rob, and I think really fascinating with your background in automotive or OEM. You know, as you've worked extensively in that sector, maybe how do you look at the drop in demand from EVs, and maybe what are critical success factors you could see to push back the demand and get demand back? And maybe also a bit of, from your experience, how has the pandemic impacted the supply chain, and how do you propose you make it more resilient, especially in light of climate change related unforeseen circumstances with this? What do you, Rob? Oh, sorry, Rob, you're muted right now.
Yes, thanks, Simon. Sorry about that. And good afternoon, everybody. Yeah, I think anybody working in and around the battery industry will be watching intensively what's going on at the moment, because we're in, I think my summary would be, we're in a state of flux or change going on at the moment around demand. And we're seeing a slowdown, as we know, in the, technically speaking, in the global growth of EV adoption. So EVs are still growing around the world. That's good news. But if we look at the rate of growth, it's definitely slowed. Everybody will be aware of that. I saw some figures from Romotion recently showing still growing from 23 to 24 half year result, about 20%. So still some growth. But that, if we compare to the previous year, 34% global growth, 55% the year before, you can see that it's slowed, and it's certainly behind where most of the industry observers were predicting. So battery penetration market share is about a fifth of the total global market at the moment, which is probably a little bit behind where I think the industry needs to be, you know, at this stage of its development. But on the good side, you know, if you look at a lot of forecasts going further out, I saw some from EV Volumes, JD Power the other day. They're still forecasting 40 million vehicles, about half the global market by 2029, from where we are today, maybe 15 or 16 million. Bain, we're talking about quadrupling of gigawatt requirements by 2030. So, you know, the underpinnings of the industry are still there, but what we're seeing is this very distinct slowdown. There is a clear marked regional disparity, though. Everybody will be aware of that. So if we see and look in China, which is by far and away the most important market, their sales are still up 30%. And, you know, the penetration of electric vehicles overall is nearly half the market. So that's by far and away the most important market, as we know. Europe's market share for electric vehicles is about 35%. US is down at 8%. And the growth levels have slowed quite markedly in those two markets. So it's quite pronounced. The regional differences that we're seeing are more than we expected, certainly in Europe and the US. So we're getting stories, lots of reports about overcapacity, overproduction going on, both at the EV and at the battery cell production levels, overcapacity, particularly in Asia. On top of that, don't forget there's a distinct swing out of full electric vehicles towards plug-in hybrids. So that's very pronounced around the world. and is a very important factor that we're seeing. It's affecting, therefore, some regions more than others. But you can see that in China, for example, nearly 3/4 of the market in battery vehicles is plug-in. 2/3 of the market in Europe, a little bit less in the US. So, you know, are plug-in hybrid the interim step that everybody expected? Is a question that everybody's asking themselves. Lots of car companies are now announcing that they're pushing back the rollout of their new electric vehicle models. Companies in different regions are facing different problems. If you look around, you know, the financial results of a lot of electric battery companies, electric battery manufacturers, you know, they are now starting to show some financial signs of distress, if you like. A lot of the car makers that are soulless electric vehicle, like XPeng, Dongfeng, like Zeekr, NIO, Leap, and others, Rivian, Fisker, you can see are starting to drift into financial issues. So I think even Tesla have seen a halving in its profit before tax over the last 5 years. So a distinct change in the market as we're moving out of what we might call, you know, early adopter phase to mass market phase. So as Aaron and Jennifer have already mentioned, real focus now on everybody in the market around costs, reducing your production costs, leveraging the value chain, and lowering the cost of all the minerals and the chemistries that we're using in the battery. And we're seeing some changes in consumer sentiment that are driving some of these changes, you know, in a sense, hesitation in the marketplace around costs, particularly around charger distribution, around government incentives. And of course, we're even seeing issues to do with trade tension between the different parts of the global market. So, yeah, the market is now in a state of flux. You know, survival is not compulsory, as I often say. And I think the companies that are going to survive in the future are going to be those that can be the most agile to this kind of adapt to these changes that are going on, and are going to be the most competitive in terms of getting their costs under, you know, under control and stable.
Excellent. Thanks so much. I really appreciate the insight and a takeaway, you know, state of flux. I think it's a
that's right.
Good way to look at it. I think with this, Shada, I would like to pass on for your next question.
Yeah, thank you very much. So we have a quick cross-panel question, and after that, we can take some question coming in from LinkedIn, and we can maybe quickly address this question to all of the panelists. Given the rapid advancement in battery materials and technologies, how do you foresee the regulatory landscape evolving to ensure safety, sustainability, innovation in battery manufacturing and deployment? Who wants to take that question first? Maybe Jennifer?
Sure. Well, so I think we're seeing a lot of evolution in that space. You know, the EU battery regulation that's coming into play is kind of a landmark regulatory framework for the battery ecosystem that everyone's having to adapt to, that I think is certainly driving innovation, and also making countries, particularly very established players like China, think about how they're going to continue to sell into the European market. Obviously, China's had over a decade of scaled battery production, whilst they, you know, they kind of made all of the mistakes that they were going to make, and now that they can turn their hand to really making their battery ecosystem incredibly green. So I think it's going to be quite difficult for North American and European markets to both get to scale and within strict frameworks like the EU battery regulation. We're also obviously seeing as well on the more kind of policy incentive side, there's a real kind of incentive and kind of disincentive wars going on at the moment between the three main manufacturing areas, Europe, North America, and Asia. Things like the foreign entity of concern policy in the US about whacking massive tariffs onto Chinese manufactured BEVs. Also things like the the IRA and bipartisan infrastructure law that we've heard a lot about in the last year and a bit that have really helped North America to make massive investments in securing the future. So I think we're only going to see more of this as we go forward, and it's going to be really interesting to see how it kind of plays out where there are continued restrictions on the major nations like China, and how what levers they will pull to ensure that they can continue to retain and gain more market share.
Yeah, thank you very much, Jennifer, for these insights. Yeah, there are a lot of incentives to slow down the China, of course, and promote, let's say, regional battery production from both Europe and US. Aaron, you want to add something on this question?
Sure. Agree with everything Jennifer said, but I think it's interesting to look at some of the policies that have come in place within the Chinese ecosystem. So one is the banning of NMC for Chinese BESS, which has really helped accelerate the uptake, especially LFP and potentially sodium ion in that space. And then the second is looking at the standards that they're setting and the minimum requirements that your cathodes or cells have to be achieving to enable government subsidies to be continued. And these standards are being continuously pushed and accelerated, which I think really shows the appetite for the Chinese industry to continue to innovate, continue to push their materials, and potentially make it harder and harder for non-Chinese based companies to come and enter the space as these Chinese companies improve their materials and ship them around the world.
Yeah, thank you very much, Aaron. Yeah, excellent point. Yeah, China continue to innovate and continue to advance their technology and try to catch up with what is demanding now from the West, basically. And Rob, do you want to add something on this?
Yeah, but perhaps just to add maybe some supply chain observations as well. As Jennifer mentioned, the EU battery regulations. I think what's interesting is this is probably one of the first examples I could think of where government, consumers and investors' concerns are being encapsulated into, really strong regulations that are now around product integrity, also around ESG, as Jennifer mentioned. Europe is leading the way. Maybe the US will follow, I think, and maybe parts of Asia will follow. And ultimately, the whole global kind of infrastructure will need to take a look at what these regulations require. But from a supply chain perspective, they're very, very important, because what we're really talking about is, what's happening down your supply chain matters. The digital passports that will come into play with the battery regulations will mean that the whole life cycle matters. Right back to the mine, you'll need to account for, what's happening in your supply chain if you're a battery manufacturer or seller. So, CO2 measuring, responsible sourcing around ESG concerns, around labor terms, around working conditions and fair wages and so forth, right down your supply chain, recyclability and recycling targets and so on. So as we've already talked about, this means the whole industry needs to move a kind of quantum leap, actually, from supply chains in terms of supply chains to manage the vertical supply chain right down to the source of the minerals and the chemicals. And that is something that's new for this industry, but it's also something that's really quite new in supply chain management. So I think, again, we talked about a revolution earlier. I think this is, again, an industrial revolution for the value chain. And so, again, I think competitive advantage will come to those companies that harness it the most effectively and the quickest to the market with it.
Excellent. Thank you very much. Yeah, that's getting really an exciting discussion. I think we have now many questions from the audience from LinkedIn. I think I hand over to Simon for a couple of questions from the audience.
Thanks so much, Shada. And I think, it's wonderful to see all these questions coming in from Soma, Renee, Battery MBA alumni, and Yannick, and Sonu, Asina, Didier, Faisa, Justin, and Jade. So a lot of questions. So let's get ready. And we might do a bit of a speed round in the end to make sure we address most of them, or hopefully all of them. I think the first question I would like to go with is from Justin. I think it's maybe also a bit in your quote, Aaron, but of course also happy to have anybody else thoughts on that. So here we're looking with the increased energy density of LMFP. How do you foresee the market share of NMC batteries and other, I guess, nickel-containing chemistries?
This is a great question. Partly because it lets me do a nice little plug, which is we're doing a webinar on this exact topic, the battery share, on Thursday. So if you're interested in hearing CRU's thoughts, please do come along. But I think LMFP is a really interesting and exciting technology because minimal cost increase, relatively good increase in performance. However, cycle life is still pretty low and adoption is incredibly low because of that. So I think in the short term, it won't displace NMC. Maybe in the medium and longer term, as cycle life improves, it will. Currently in China, it's being blended with NMC, so kind of used in hybrid. So maybe we'll see more and more LMFP in those blends over time as the performance starts to improve.
Perfect. Thanks. No, thanks for the plug. Might check that out. Great. I think Shayla, do you want to ask the next question? Do you want me to go? I can also go otherwise.
Yeah, I can ask the next question. Faisal, he's from Morocco, and he thanks very much for this excellent discussion. And his question is, what are the challenges and recommendations of sodium-ion technology? Maybe Aaron, you want to continue on that, or we can maybe Aaron and Rob can collectively answer this question.
Yeah, happy to go. Rob, do you want to go or should I go?
No, I think it's a technical one, Aaron, that you're probably best suited to talk about, I think.
Cool, perfect. So I'm really interested in sodium ion for a couple of reasons. One is if you want to build a supply chain that isn't dominated by Chinese companies, it's going to be quite difficult to do that if you don't adopt sodium ion, simply because Chinese companies have really big ownership of the lithium mining, the anode space, the cathode space. Currently on the cost side, the real limiting factor is the anode. So the anode is typically hard carbon. It's made very similarly to how graphite is made, but there's just not really a supply chain for it yet. So the prices are very high. They were even higher. They're coming down as more people produce the material, but it should keep coming down, which will enable sodium ion to be cost competitive. And then on the performance side, I mean, sodium ion technology won't be as energy dense as lithium ion, simply because sodium's heavier elements is pretty difficult to overcome that on the energy density and performance side.
Thank you very much, Aaron. Anybody wants to add anything on sodium ion, Jennifer or Rob?
Well, just not specifically about sodium, but I think the point that Aaron touched about, I think the technology race that's on around energy density and looking for different minerals and chemistries that can give us the best solution is critical technologically and technically speaking, cost speaking, but it's also from a supply chain risk point of view critically important. And as one or two people have already alluded to, China right now dominates the refining side of the business for historical reasons and because they are by far and away the most important market. And for other parts of the world to get a slice of the action, if you like, in what will be a global industry, it's important that they can build up their own mineral solutions and mineral processing solutions that can compete, if you like, with the dominance that we can see in China. And if you think about cobalt or nickel or lithium, the refining of those minerals is dominated out of China at the moment and is likely to remain so when even many of those refining systems go out and globalize. So if there are new minerals like sodium, to Aaron's point, which can be exploited and are readily available and low cost elsewhere in the world, then that's a great opportunity for indigenous manufacturing and refining to go on somewhere else in the world. So we should look to do that to diversify and improve the choice and competition of the industry.
Brilliant. Thanks so much, Rob. And I think you're kind of, tying some good questions together, because there's a lot of discussion about China and questions about China now. I think we can maybe address this a bit more, maybe get also your thoughts on this, Rob, but maybe also Jennifer from a processing standpoint, because there's also some questions on dry coating. And yeah, I think it's also kind of nicely aligned. I mean, Aaron, you are plugging your webinar, or maybe I plug some of our videos we just released on China, because we spent a few weeks there and we recorded many videos. We released one just today on lead acid, which is one of these other technologies many of us don't really think about much. There's also some interesting business case to be observed in China, but of course also sodium ion and other technologies we released over the past weeks. But now to the question for Rob, and I will kind of tie Renee's and Yannick's question a bit together. So the question was from Renee: with low production costs by Asian players, technological hurdles at domestic emergent players, how do you assess the viability of EU headquartered gigafactories such as Northvolt? Should they focus on newer technologies such as dry coating? Here may be a link to Jennifer, LMFP, or stay with the same field as the Asian players. And that's also, I think, Yannick, in the same line. The question is whether Europe can compete with China, as the markets are predicting to be flooded by cheap EVs from China, BYD, say Xpeng, etc. So maybe Rob to start with, maybe Jennifer to add some technology.
Yeah, it's a great question, because I saw some information the other day that I don't know what the number was precisely, but it's certainly over 30 new plants are either under construction or, some are in existence. Of course, some are under construction or being, on earmarked to come on stream in Europe. And there's a similar picture if we go to North America, and even a bigger picture, as we know, in Asia. So I think it's going to be a combination of what we might call transplants. That means we'll see inward investment, and we are seeing inward investment from a number of the big, what we might call global battery players from China, from South Korea and Japan, coming to Europe to produce locally here. And also we've got hopefully a number of, let's say, indigenous local startups like Northvolt and others that can make it through and offer solutions. But as the questioner asked, the key one is how to be competitive at the end of the day, and there's no free ride for anybody. So quite right, I think the question was saying, are there ways in which you can become more competitive through technology? There has to be, I think, for you to be successful here in Europe, which is traditionally a higher cost base. And also, how can we improve the production method and let's say, lean the systems out? What we shouldn't forget is, the internal combustion engine has had 100 years to improve its manufacturing processes. And the battery industry, to be fair to it, has only had a decade or so. And so there's a long way for us to go in the battery industry to match up in the performances and the manufacturing efficiencies, yields, and the OEEs that we need in the battery factories and so forth need to be honed to perfection, let's say, in order to be cost competitive. So there's a lot to do. And there's no reason why Europe can't be at the forefront of that and be competitive, in my view, provided it's well managed.
Yeah, I absolutely agree, Rob. If you copy and paste a gigafactory from China and put it in Germany, the German one's going to be more expensive. There's just no way of getting out of that situation. So process innovation is going to be absolutely key for Europe and North America to achieve a lower cost, better performing battery. So yeah, that's absolutely my perspective as well.
Excellent. Thanks so much. And with this, maybe Shada, do you want to ask the next question?
Yeah, perfect. So we have a cost-related question now from DJ. What is the target battery cost that the automobile industry would consider to be low enough to address the needs of the mass market for EV? It used to be $100 per kilowatt hour. Is the magic number or much lower now? Who wants to take this question? Again, maybe Jennifer, you want to take, and we continue with Rob?
I can speak generally.
Yeah.
Lower cost is always going to be better for mass adoption. Rob spoke to this point earlier. We've seen the early adopters, and now we're at the mass adoption phase, and cost is absolutely king in that equation. I think there's, the materials price is an interesting one, and we've seen how volatile they are and how much that impacts how much that impacts the cost of the battery, and it's been dropping over years, but we've seen an inflection point as well. Again, processing costs could be a way to help stabilize that cost. But I think when we think about the mass European market adopting EVs, cost is going to continue to be important. Maybe Aaron has more specifics on the numbers and the trajectory of packs, but yeah, I agree.
I'll give a typical very annoying answer, which is it so depends on the size of the vehicle, what the battery size is going to do. I mean, we previously saw battery sizes increasing, but now that's started to come back down, and we think it will continue to decrease. So if your battery size is decreasing in terms of kilowatt hours and your dollars per kilowatt hour is decreasing, your total dollars that you're spending on the battery is obviously coming down. I think maybe the target would remain at $100 a kilowatt hour, but there's going to be continuous innovation to push those costs even lower to really enable, I guess, quicker adoption of electric vehicles, which is something I think that we're all kind of hoping for and rooting for, especially on this call.
Yeah, maybe just to add to Aaron's comments there. I mean, I think, I've put my old purchasing director's hat on, unfortunately. My view would be, and I would say this to the battery suppliers, I want parity. So in other words, I want, through the technological and process innovation that we talked about, I think the market wants electric propulsion systems to be essentially the same price as internal combustion engine. At the moment, certainly the data, going back a few years from my time, was that there was a significant cost penalty to fit electric propulsion system. And on a like-for-like basis, we know if we're going into the dealers to buy a car, we're facing 30 or 40% cost difference to buy an equivalent car in electric vehicle mode versus an internal combustion engine. So I think the industry has to eradicate that gap, and that's easier said than done. And it may take longer than simply a couple of cycles, let's say. But I think that's ultimately where we've got to get to. That really, this new technology should offer us ultimately lower costs, and the industry's got to figure out how to do it, and it's got to figure it out very quickly.
Yeah, just to add to that point, I think most of the European market's been focused on introducing more premium vehicles as their kind of market leading BEV. And what that's afforded China the opportunity to do is to produce a lot of cheap BEVs that could address that gap in the market. And now Europe and North America have realized the error there and are trying to introduce ways to prevent this influx of cheap vehicles from China. So yeah, I think we need to have a bit of a rethink about what we're doing there to continue to allow that mass adoption of BEVs, but also make sure that we're benefiting regionally from that transition.
Excellent. And looking at the time, we're getting to the end of it, and of course now we get a question every few seconds, so it's we're trying to stay on top of it. So I might kind of do a bit of a potpourri now of a few questions we're having here, and you're welcome to just choose whatever you're most interested in, maybe all of our panelists. So just on a few topics we want to address. So one is, there was a topic about solid state. I'm not sure if anybody here has any thoughts on that, when this might come, when we can, a lot of people waiting for that still for some time. If there's any thoughts here, anybody wants to share anything on that? I think then there's also some curiosity about the dry coating processes from Jennifer. A bit of the question, when can this be potentially be scaled up? I think that's a question when this might come, if there's anybody brave want to share that.
Well, I think on solid state,
please.
I mean, a lot of reports, Simon, are saying, a number of car makers and battery makers are sort of saying they're close to being able to offer, let's say, in mass production, a solid state battery. But I know traditionally one of the problems was cost. So you can't add a solid state battery if you're going to add cost. But if you can get the range down and the energy density down to what is promised, then you may be able to go with a smaller battery. And as Aaron says, the trend is to smaller batteries as we extend the range and the energy density. So solid state was always seen as going to be a kind of breakthrough technology. And it's around the corner, I think, if you look at the reports of some of the car makers at the moment. But whether it will give us the breakthrough that we need in the cost area is what I'm most concerned about, to be honest.
Yeah, and I think certainly what we're seeing is that the dry coating can be very important to addressing some of the cost element of a solid state battery. We've seen some announcements recently of some of the big players talking about when they're targeting bringing dry coating to market at scale. So LG Energy Solutions, they announced, I think it was just 2 weeks ago, that they're targeting 2028. Last year, PowerCo announced that they were targeting 2027, which also coincides with the release of their 20,000 euro car to the market. So I imagine there's some correlation there. So I think those things could go hand in hand, actually. And it'll be interesting to see how the market evolves over the next few years.
Yeah.
Excellent. Aaron, anything you want to add on that? Or
I guess I'm pretty skeptical of solid state, partly because of manufacturing challenges and partly because of the challenges integrating it with the car. Specifically the pressure needed to enable those interfaces to connect. But I agree with Rob that once those technical challenges are overcome, the next challenge will be, can you do it cheap enough that it makes sense within the vehicle?
excellent. Maybe also something quick to share. Of course, there's also then the topic of lithium metal, which is not always connected to solid state either these days. And there's of course also other approaches. You can do liquid electrolytes actually with lithium metal. We just released today a podcast on that on this LinkedIn page if you're watching right now. So if you're curious, feel free to look at that as well. There's also the topic of recycling. I'm not sure if we have time for that. If there's anybody here quickly wants to share anything, the importance of recycling maybe to make it all work. Rob.
Yeah, well, the only thing is if you look in the detail of the EU battery regulations, which I recommend people take a look at those, there are some pretty prescriptive requirements around three things. One is, designing for recyclability at the beginning, and this is not just the battery system, by the way, but other parts of the vehicle as well. So can we design for recyclability? Then what do we actually get out in terms of recycling? What can we actually extract economically from the vehicle at the end of its life? And you can see a lot of car makers now investing and partnering up, collaborating in various ways on the whole issue about salvaging the various minerals and metals out of the vehicle, and including and especially battery. And then finally, there's requirements around closing the loop. So using some of those metals to put them back into the melt for the next generation of batteries and so forth. There are also other areas, of course, where we can use second life batteries, or we can use vehicles attached to the grid and use them to effectively act as an offload overload system. So there's a lot of areas in this whole area about sustainability and recycling that are going to be really important for this industry. I think it's a huge new area that the industry has not traditionally looked into.
Fantastic. No, thanks so much. I think we really appreciate your perspectives you shared on the future of batteries. I think we really went through quite a few topics here. Again, there's many more questions now. Look at also from Camille about African-based gigafactories and many others who you shared your question. But Lisa on pricing of solid state. So unfortunately, we don't have time for this now as part of the public part. I know some similar questions already been asked here internally from the current cohorts. We're going to go into them a bit more in depth. And for now, I really want to say big thanks. Also, maybe I have one last poll Shada can pull up. We actually asked some of you before for some of your opinions, and we don't have really much time to discuss this now. Here, we might discuss a bit more internally with the current cohort, looking at some of the topics of what are the main challenges of bringing battery costs down. We've seen here expensive raw materials, something Aaron, you addressed earlier, and kind of also mentioned how the price relaxation there, the cost reduction has really helped the price to go down. But of course, going further down, raw materials are still a topic there. Also high regulatory compliance, maybe in some regions more important than others. High cost of energy, of course, in some regions more important than others, but also shortage of talent, definitely something we observe a lot with the battery MBA and the battery associates in general. So I guess that's also part of why we are here, to really trying to bridge a bit of the gap of shortage of talent through the battery MBA, but also many other trainings we are launching in the battery space. So for now, we do want to say a big thanks for all of you watching live. I see a lot of debates going on in the chat, so keep them going. Maybe we can answer each other some questions. If some of the speakers can look at this later as well, we might also try to answer some of the questions or give you some of our thoughts in there. But really, always appreciate all of your engagement online. So really, really appreciate it. And again, if you're interested in joining, don't hesitate to look at the next cohort starting in September. Would love to have you with us there as well. It's really great fun. With this, thanks everyone for the public part. We're going to go into the closed part now. Brilliant. So everyone can relax for a moment. Everyone now is welcome to turn on their cameras. we keep the recording running, but of course the live stream is done. So also if people now want to turn on your cameras, Barath, if you can make it available that everyone can ask questions, that would be amazing. So we're not just ourselves here, because of course, big part of it is that it's engaging. So would love for everyone who is available to turn on your cameras. Not sure if you're not able to, or if Barath, if you can make sure that this is available for people. Oh, great. DC coming up there. Perfect. Wonderful. Lucy, Eric, wonderful to see you all. Great. So maybe, Shada, I will pass it over to you to ask the first question in the chat from Juma.
Yeah,
Sure.
thank you very much. It was a very enlightening panel session. I really enjoyed, and now we look forward to the questions from our Battery MBA participants. First questions from Juma. Juma, if you want to ask, you can directly ask, or I can read it. You read your question to the panel.
I think it's just simple and straightforward. Look, coming from the African continent, the context is that we have always not been able to keep with technology, especially if you're going back to the era before computers. But we have shown a great resilience when it comes for us to advance quickly and adopt technology. And at the moment, we're talking about battery gigafactories, and I don't see any countries, especially Sub-Saharan Africa, discussing the concept of gigafactories. So can we be consumers and be mass adopters, or we must set up gigafactories that are regional for Africa for us to advance the usage of batteries, both for EV and secondary storage?
So I think for Africa, it's interesting because you guys have a lot of the upstream materials that are needed for batteries. So I think that's where your biggest play will be in the industry, is in the mining and refining aspect. For your own domestic supply of batteries, I think it depends on whether you have the OEMs there that are going to be taking up those batteries. So that would be my kind of perspective, that Africa's main role is going to be supporting and able to capitalize on your natural resources to supply the global market.
Yeah, just to add some thoughts to Jennifer's comments, because I agree with what Jennifer said. I think that there's a couple of things to think about. Africa is also, I mean, Africa is a source, North Africa particularly, as you know, is a source of quite a considerable range of different automotive components right now. So it's supplying already into the automotive industry, particularly from places like Morocco, Tunisia, and other parts of North Africa. And I think one of the key things, and when we think about cost and how are we going to kind of revolutionize the cost of this industry, then as Jennifer says, what's interesting is many of the minerals are coming out of parts of Africa, and maybe the refining can be done economically close by. And one of the biggest problems about batteries, of course, is they're very, very heavy. So moving them is one of the biggest constraints and geographical location. But who's to know that you couldn't assemble cars close to the mineral refining and the mineral extraction in Africa for the future, especially if you've got skills and experiences in that part of the world which are developing very quickly. So I can imagine in the future, that we may see vehicle manufacturing going on in Africa, parts of Africa, close to the minerals, close to the refining. So that's a real opportunity for Africa to be able to, let's say, contribute and be part of this industry for the future, I would say.
And if I can just jump in real quick, there's a lot more lithium mining currently taking place in Africa in terms of exploration and mining. But there also are a couple of projects looking at building gigafactories within Africa. One called Afravolt, and one that I've forgotten the name of, based in South Africa, looking to build factories to produce batteries. So I think those could be interesting, because obviously there's going to be a huge demand for batteries within the whole continent. And if there's the opportunity to supply in certain regions, transport that lithium and then build it within the continent, I think that would be pretty cool. So there's a few projects ongoing try and build locally as well.
Thank you very much, Juma, and all the panelists for interesting insights about Africa region minerals, and it will be maybe future innovation hub in battery technology. So we continue with the next question. Irina, would you like to ask your question?
Yeah. Thank you very much for this really interesting idea of the round table and the topics that we discussed during the event. My question is about your vision regarding of the current EV technology's applicability for trucks. It's not a secret that trucks have to make longer distances in comparison to normal vehicles. That's why current technologies don't allow them to make these distances without extra loading. That it can also takes a lot of time. How you can predict the future of trucks technologies in terms of EV market?
I think for trucks, there's kind of two schools of thought. I think one is battery technologies will develop to a point at which they can service the various different duty cycles of a truck. The other school of thought is that hydrogen will be the answer for trucks. And by the way, when there's hydrogen involved, there's still a battery involved. I think I would say the jury's out on exactly how the market's going to unfold around trucks, but I think it's going to be a combination of technologies. I don't think it's going to be kind of necessarily one or the other.
Yeah, I would echo that. That was similar to my thoughts when I heard the question, really, which is that I think maybe light trucks, there are some possibilities, but we have to think about I think the average weight and size of the battery has to come down, which means the energy density breakthroughs are needed that we talked about earlier. As Jennifer said, a lot of discussion around hydrogen or even hydrogen combustion, which still has some emissions, maybe as an interim or stepping stone to that. It's difficult right now to understand whether the technology is going to be available to pull big trucks or big earth moving equipment, etc., depending on the duty cycle. So it's another area where, again, because we're in this revolution, there's how can we adapt the best technologies to decarbonize the way in which lots of our goods are transported around the world. That's another key challenge.
Excellent. Jennifer, you want to add something? Yeah.
I was going to say the other thing is total cost of ownership is a big component when looking at trucks, and there's other technologies, new chemistries coming into play which enable longer cycle life. So anode chemistries, for example, such as niobium oxides, seem to be doing quite well in providing significant enough energy density, but also long enough cycle life to service some of the duty cycle, but also that longevity, total cost of ownership requirement for trucks.
Excellent. Thank you very much. We continue with the next question now with Edward. I think it's a regulatory related question. Edward, do you want to ask your question, or I can ask it for you if you can't?
Yeah, I can ask.
Yeah,
That's
perfect.
fine.
Thank you.
Yeah. So I think it was answered earlier, but then I just wanted to find out what the logistic will play out in terms of the extended producer responsibility in relation to the EU battery regulations. So, it says that producers should be responsible to finance the entire recycling of the batteries they place in the market. So I'm under the assumption that OEMs in this case should be a producer. And given your experience with Jaguar Land Rover, I just want to ask if you know how the logistics will play out. So for an OEM, does that mean that they produce, they finance the take back scheme, and then they take ownership of that batteries, then sell it back to the manufacturers, or they just hire the recycling companies as service? And then, just want to ask what your thoughts were on that requirements from the regulations.
Yeah, so I mean, we touched a little bit on it earlier, where you could see a lot of the automotive companies have now invested in or are investing in setting up their own recycling or recovery businesses, or collaborating with existing players in this area using technology to extract the various minerals and so on, and including Jaguar Land Rover have done some of this. So I think the answer is, right now, the business model of how that's going to be effectively managed is still kind of in evolution, I think. So you're raising some really good questions about, how do we actually make sure, first of all, everybody takes their vehicle back to one of these outlets that can actually do the extraction? How do we incentivize the consumer, when they may be the 5th, 6th, or 7th owner of the vehicle, to do that? And this is why I'm talking a bit about a revolution, really, because right now, if you look at the traditional way in which cars are recovered, or scrap cars are recovered, which is mainly for the metal and the steel as we know today, then it falls quite quickly out of a kind of organized structure into what you might call kind of a disorganized market, in a sense. And I think the car makers will have to take more of an active role in this area in the future than they have done, because the regulations, as we talked about, means that they're going to have to evidence where their products are being recycled. So I think that will still be a collaboration. I can't see the car makers wanting to own all of that value chain. I think they will use partners and suppliers to do that. But I think we're looking at a completely new level of collaboration that's needed in what we might call traditionally the scrap industry, than the way you've seen it play out in traditional cars. So it's another big space for people with good innovation and good management approach and business models to make money. It's another good area for us to look at in the industry.
Yeah, definitely. Any other panelists wants to add something on this, Aaron or Jennifer? Or otherwise, we can just continue with the next question, which is interesting. It's about EV sales drop. So Kelly, would you mind asking your question?
Yes, we might have beaten this to death a little bit, but Rob was talking about the slowdown in EV sales, and we talked about driving the cost per kilowatt hour lower and potentially driving operating costs. But when I look at the price difference of EVs today in the US, they're still like $20,000 more expensive than the lower cost combustion engine vehicles. So even if we were to get to that very low price of raw materials and reduce operating costs by 30% by switching processing, are we getting close to that comparable combustion engine price, or how do we get there?
Jump in and say that in China, cost parity has been reached, especially on some of the smaller range vehicles. And I think both Rob and Jennifer mentioned this on how the European approach has been, or I guess the US approach too, is let's build really big, expensive EVs and not make any money on them as well, which I think is maybe an interesting strategy. But so even I had this conversation the other day, which is even though the cost to produce the battery may be coming down, the major OEMs still aren't necessarily making money on their EVs. So I guess one time as manufacturing capabilities ramp up, two, as those cheaper battery prices in China kind of filter through and you can make it homegrown, will probably help reduce that cost, and then maybe smaller vehicles to begin with before the energy density continues to increase and enables like your high-end cars. That being said, I'm going to disagree with myself, which is the BYD supercar that we saw the other day. They announced it a couple of months ago, and it was out at Goodwood. Is like a good example of how cheap technology can be used across the space, and you can achieve, I mean, that's extreme high price, but matches the other extreme high prices. But then the LFP can also match like the low price scenario. So I think it is possible, but I guess choosing which vehicles we should start with or continue to push forward may be key in enabling that parity in the Western countries.
think just to add to that, Kelly, I think it's a really good question because, you know, without being too cynical about it, I think what we can see currently in the marketplace is actually what's been happening is actually giving, in my view, the traditional car makers a bit of a breather. And you can see that what they're doing is looking at how they can extend. And so I think that my personal feeling is that, you know, they're overblowing this slowdown as such, and they're not supporting the transition, if you like, because it gives them more time to adjust their industrial infrastructures to what we've been talking about, which, as Jennifer said earlier, is really, you know, we've been focusing on early adopters who want every gizmo on the car at very high value. And now suddenly we've got to now move to mass market. And whoa, we're not ready. And, you know, what we can see, therefore, some of the trade tensions are, I think, because many of the traditional car makers, you know, are simply not ready to compete with what we can see is now being produced in Japan, in China. So there are some precedents to this, as I've been around long enough to remember that happened to the car industry when the Japanese suddenly became, you know, dominant, and when the South Koreans became dominant. So I think one of the bridges, I think, would be that we're going to see the advent of Chinese transplants in Europe and in North America. So one of the ways in which I think it will happen is that they will come. Anyway, I think some of the trade barriers will kind of, in a sense, force that to happen. And you can already see now evidence where the traditional car makers are collaborating with some of the Chinese car makers. I noticed Stellantis were doing a deal with Leap, for example, where a whole range of Chinese vehicles were going to come in, but be badged under Stellantis. So watch out, because I think this is why I'm talking about, you know, the amount of flux going on, and who's going to survive is not mandatory. So I think the next 5 years are going to be quite interesting and exciting, because I don't think everybody can survive in the current way the structures of the industry operate.
Yeah, just to add a couple of extra points, I think, so in Europe last year, we committed to banning the sale of internal combustion engine vehicles in 2035. There was some talk previously about whether that would be 2030, but at least in the UK, but it's been confirmed as 2035. Then if you look at countries like Germany, they've managed to get some sort of special dispensation, and it's 2040 for them. And they've also removed the kind of tax incentives that there were for purchasing BEVs. So I think things like that can have massive effects on uptake as well, especially given that $20,000 premium that you're talking about on buying an EV. So yeah, I think the market is very sensitive, and the automotive OEMs, they have committed in a big way to producing EVs with masses of investments, but I think the profitability of those, as to what Aaron was talking about earlier, is still they're still struggling with that, and so they're prolonging ICE sales for as long as possible to try and retain that profit margin.
Yeah, thank you very much for that. Yeah, actually, around Europe, in Ireland, where I'm now, there used to be some grants for EVs, not anymore. This year, it was all gone. So yeah, it's a bit sad, but so the next question is from Shreyas. It is some points we already addressed during the first part of this conversation. But I think the second part of the question, maybe you can ask that, Shreyas, if you want to get more insights on that. Okay, I can ask maybe. She asked, what is your view on China's lower cost kilowatt hour, but having higher emissions for that kilowatt hour? Rob, you
Yeah,
you want to go for that?
It's a very interesting question, and it's one that we can see the media play around with as well. I mean, I think, and at risk of being shot down by somebody out there who's a lot more expert in this area, but I think generally speaking, it's accepted that it's better to have an electric vehicle from a total lifetime emissions point of view than not, compared to an internal combustion engine. But the problem is the halfway mark, where you're powering that electric vehicle either through a hybrid engine or, of course, through non-sustainable electricity generation. And then you've seen the graphs, you're only halfway to where you should be. And by the way, when we get to full battery electric off sustainable energy sources, we're still not right there, because we've still emitted a lot of emissions in the in the manufacturing and the processing of the battery system as well. So the answer to the question is really that, you know, we're just making progress. We're not where we need to be overall. And we know that climate change is really is driving us. We have to do this as humanity. But we can see already, if we're involved in the industry, you know, it's not a straight road. And as Jennifer alluded to, some of the regulations, you know, there may be some political pressure on governments and local regulations, cities and so on, to actually kind of alleviate some of these challenges on internal combustion engines. And we can see even in the UK with the recent thing to do with ULEZ, where, you know, the public are these are not very popular measures. So the answer is China will not be producing perfectly green cars, and neither will anywhere else in the world. And we've all got a lot to do to get where we need to, is probably this, which is why I was chuckling a little bit, because I think there's a long road ahead for us all.
Yeah, I agree entirely. And it kind of comes to the point I was saying earlier, like China's already scaled their battery industry. They already know how to make these things super efficiently with very high yields and very little scrap. So with the EU battery regulation coming in, that's going to control things like the amount of CO2 that's embedded in a battery, you better believe that they're going to be working on how do they get that CO2 emission per kilowatt hour down, so that they can continue to sell into the EU market. They don't want to, cut their noses by their face.
Yeah, I mean, I agree completely, which is just on top of that, that the Chinese industry is massively decarbonizing. We track their emissions, like on average, and it varies very much region to region, but on average they've come down from 0.7 to 0.6 kilograms of CO2 per kilowatt hour in the grid in the last 4 or 5 years. So they are reducing. There's no doubt that they are more emitting on average, but there's a big push within China to install solar panels and whatever it might be to reduce that emitted carbon.
Okay, thank you very much for this. Yeah, I think without China's effort, we can't be able to reduce the carbon emissions in battery industry. We're so dependent on China. And the next question is from Mikola. I think if you want to ask your question, Mikola.
Yes, thank you, Shida. Thank you, everybody, for such a great conversation. And actually, it was really interesting. And I'm curious about development of gigafactories in European Union, because we have seen a couple of years ago it was kind of boom, and we have seen a map with lots of projects in European Union. I think it was around 30 or 40 of them planned with big capacity, with increasement of the capacity, so on. And right now what we can see that actually a couple of the gigafactory projects, they were frozen, cancelled, suspended, and kind of less optimism, I would say, we can see in terms of development of the gigafactories in the European Union. And also I can understand that it is kind of issues related to the European regulations and also hydrogen development in the European Union. Just could you share your opinion about the future of the gigafactory projects development in European Union? Thank you.
I think
yeah, you go, Jennifer.
I was just going to say, I think, you know, we've learned that it's really hard. I think that we've gone through an initial boom phase where there's been lots of investment available for these types of projects and lots of ambition. And, you know, from the UK perspective, Britishvolt was obviously a high profile casualty of that, of that kind of boom. So I think that's why we're starting, well, we're seeing a lot of kind of joint ventures and programs like that, where OEMs are partnering with the experienced players to make sure that they can get something set up in Europe and do it without sacrificing on yield and ramp up phase and things like this to get something to market as quickly as possible. I think it's natural with any kind of nascent industry that there will be casualties along the way. This stuff's really hard, and I think obviously the media likes to play up to these challenges as well, and we've got, combined with things like slowdown in rate of uptake, there is still the amount of EVs that people are, it's still a positive trend is what I'm trying to say, but the rate of uptake slowed down. So I think we're in more of a challenging economic time, but I still expect that we will see many gigafactory projects come to succeed in Europe. It's just we're going through a difficult phase right now.
Yeah, I think I completely agree with what Jennifer was saying, because I think there's a degree of difficulty now that we've just kind of touched on earlier, which is, how many additional gigafactories do we need to meet the demand over the next 5 to 10 years and beyond, 15 years beyond, is a little bit difficult to predict now in the light of the slowdown and what all the other different variants that can affect consumer sentiment on this. So I suspect Europe is hesitating not to get itself into a situation which we can see partly emerging now in China, where they've got overcapacity in gigaplants, which is causing distress in other respects, including price cutting and so forth. And therefore balancing the right amount of capacity that we need at the macro level to the macro demand in Europe is going to be very, very difficult, especially, as Jennifer says, where you've got different regions and countries kind of competing for the economic value of the gigaplant. So I do think we're in this kind of flux state at the moment where, probably many of the investors in, and it's both indigenous players, but also, inward investors from Asia particularly, are going to be a bit hesitant, and they may start to slow the rate at which they put these investments in over the next few years, especially if the OEMs are starting to also push out their kind of new model deployment. But the bottom line is, right now, politically, the EU is committed, and so is the UK and other parts of the world, to 2035 ban. And so as long as that stays, and I've not seen any sign that anybody's backpedaling on that, then we've got the zero emission percentage goals each year for each vehicle manufacturer to meet, then we are making progress towards becoming decarbonised and ICE free. But at what pace is the question, and therefore when do we need the factories that you're talking about? It's going to be difficult.
Thank you.
Thank you, Mikola, for the question about gigafactories. So we continue with the next question. It's from David about artificial intelligence and its role in battery industry. David, would you like to ask your question?
Yes, hi. I'm curious from the panel, your perspective and what you have learned about how the AI is changing the trajectory of the battery industry. And do you have any insight on how the next maybe 5 years going to look like? What are the problems are going to change? And yeah, thank you.
I can jump in with a relatively easy answer because this was announced yesterday, which is LG are using AI to do battery design in a day. So this is something that has taken people a long time to be able to do, which is design your batteries for your application. So LG are launching some form of AI tool where you can do that pretty quickly. So that's one area. And I guess another area which I'm really interested in is looking at defect detection within manufacturing lines. If you can spot a defect earlier in the process line, you don't have to form it or wet it with the electrolyte. So then you can cut it, recycle it easier and get it back in the line. And I think that's somewhere that AI might be able to help, both on a imaging perspective, either with CT or ultrasound, or from kind of like a big data perspective, which is just being able to predict when a batch is going to be good or bad based off of surrounding temperature and pressure applied and these kind of things. So I think where there's big data and then there's optimization through that, I think that's cool. I was speaking to someone from Honeywell a year ago who works a lot in the pharma space, and their yields are like 99.99%. And we're celebrating being at lower yields, like 95, 97 is pretty good. So I think if we can get up to that stage, that would be pretty cool on the manufacturing. And then finally, I guess material discovery is obviously huge with AI. It's done in, again, pharma, but lots of other industries. There's a couple of companies working on that to design better materials with the help of machine learning and AI.
Yeah, that's some great examples that Aaron's shared. And the only other one I would add to that really is I think AI and other variants of that, things like blockchain technology and things like NLP, kind of language programming, can help in the management of supply chains and is helping in the management of supply chains, particularly as we've got to drive what we've talked about, which is this complete vertical supply chain visibility. So we need to know everything about what's happening everywhere at all times. Then I think AI and the way in which we can communicate using things like blockchain around the movement of materials between different business boundaries is going to be quite important as well for the future.
I think the other area I would add is possibly in battery control as well. So in BMS systems and things like that, where you've got lots of data, there could be a role for AI and understanding, kind of predicting faults in individual cells before they arise, that type of thing.
Yeah, thank you very much. AI will play a big role in battery industry already. It's been employed in quality control now, like Aaron said, imaging, and we see that blockchain, like a battery passport, and we also see big data as well, and battery testing, and also some new stuff in recycling. I think some AI in recycling, sorting. That is, yeah, very exciting things happening in the industry in AI field. So I would love to just stop at this point, and I will drop our feedback session, and we would love to hear your feedback on this roundtable session. And I would love to get a quick group photo as well. If you don't mind turning on your cameras and saying hi, and I take a roundtable group picture. So 1, 2, and 3. Sorry about that. It's coming now. Thank you very much for that, and we can now continue with our questions. The next question, I think, is from Mariana. Yeah, Mariana, if you're here,
yes,
and ask your question, yeah, that would be great.
Thanks, Shada, and thanks to the panelists, Jennifer, Rob, Aaron, for the very interesting discussion that you brought us on now in the past, present, and future. So a big trip through the battery world and the past, present, and future on different topics. So my question is, out of curiosity, if you were to go back 1-2 years, same time, what has happened in the battery world that since then that you at the time didn't expect? So something surprising because of its scale or because it happened faster than you have expected. So just maybe out of curiosity. Thanks.
Mm-hmm.
I think the sodium ion boom in China would be the one I would point to. That sort of felt like it came out of nowhere. I'm sure Aaron's got lots of thoughts on this.
The opposite, which is the lack of boom today.
Okay.
Which is 2 years ago, it came out of nowhere and I thought it was going to be amazing. And then lithium went to the floor. And now everyone you talk to is, oh yeah, we're still a bit more expensive than lithium, but maybe in a little bit we'll be cheaper. But yeah, kind of, I guess the boom and bust of sodium has been pretty rapid in a few years.
One of the things I'd reflect on, Mariana, it's a great question, by the way. Well, if I go back 2 years ago and I look at some of the notes I was using to talk at the university to MBA students and so on, one of the things I talked a lot about, because I think they are an incredible, flagship for the industry, or have been, is Tesla. And I had a phrase I remember on a slide a couple of years ago saying they were a lightning disruptor. And I used to show a graph showing their capital value. By the way, they're still by far and away, they're still the most valuable car company in the world by capital, capitalization. But they've more than halved since 2 years. And I think what we should reflect, what's happened to Tesla, or what is happening to Tesla, is also to some extent symptomatic of what's happening in the industry, because they are such an important part of it. And this is, by the way, I've got a huge amount of respect for Tesla, what they've done and what they're doing. But what we can see is they are now getting into what we might call more choppy waters. And, as I mentioned earlier, their profits are not as good. They're still making profit. Their capitalization is not as good, but they're still very valuable. But what they're starting to see is some of the problems that we can see and we've talked about. So the biggest thing in the last 2 years, I think, is, is Tesla stalling? This question about where Tesla's going is a kind of symptomatic for the whole industry, I think. So it's worth watching every day what happens to Tesla.
Yeah, very interesting. Yeah. Jennifer, you want to add something?
Yeah, I was just thinking, if we were to go back 2 years ago, I don't know how much we would have predicted that LFP would be such a large market share. I think we were more thinking that NMC would be increasing, but I think we're seeing more and more that LFP is taking up more of that market share and doesn't really seem to be showing any signs of slowing.
Yeah, definitely. There was lots of surprise in terms of materials. I would say when we were testing LFP 10 years ago, nobody would be like, LFP can be used in batteries. No, and then 10 years later, it was like a huge boom in the in that type of cathode. I just will continue now with the next question. I think there is a question from Eric about e-bikes. That's interesting.
Yeah, thanks, Shada. So here in New York, there have been examples in the news where someone has a scooter or they have a bike inside of an apartment. It catches fire, and now the whole building is at risk, obviously. And with more cars coming into the city too, I will just expand that as a general question of if you guys know if the local governments want to get involved more in the safety. So, for example, I think they're passing regulation here for New York City, and more than just relying on a UL certification, but if there's any talks about, city governments perhaps to have their own lab or their own safety lab, and the idea of maybe passing products through there, in order to be sold in a jurisdiction.
I would say I don't know about anything on a lab scale, but in London, e-bikes, e-scooters, that kind of stuff is all banned now on the tube. So maybe that's step one, which is blanket ban, while essentially give some time to figure out what the best way to protect people on the trains, but also people buying products that maybe don't have highest quality batteries. But yeah, I don't know about that, but I think that'd be cool. That'd be quite a cool place to work. Like free experience to blow up stuff for your government.
I think it's an interesting question, Eric, because again, this is just my kind of anecdotal, bit like Aaron mentioned. It gets mentioned quite regularly in the press and the media, and this is quite rightly in some respects, especially around e-bikes and e-scooters, as you mentioned, where there have been incidents and they get regularly reported on. But the whole consumer sentiment about the safety of electric charging is a broader concern that I think is contributing to some of this kind of slowdown about what's it really like to have an electric vehicle or electric propulsion system. And I notice regularly, in fact, interestingly, anecdotally, again, there was a fire at one of the UK's major airports last year. And it was, for a few days, it was blamed on an electric vehicle that had gone up in flames inside the multi-story car park. And it had caused a huge amount of damage, by the way. You can read about it. It was Luton Airport. Anyway, the result was it wasn't an electric vehicle, even though the media piled in that it was an electric vehicle. It was actually an internal combustion engine. The point being that I think that the industry has to be very, very sensitive to, firstly, the integrity of the product from a safety and the consumer's use point of view, but also from a kind of reputational point of view, that it's something that concerns consumers. And, you know, we're going to have to listen to our consumers very intensely to address any concerns they have about using the product. So, you know, the way we charge it is really part of that. So it's a good question to watch for.
Thanks.
Thank you.
Thank you very much. Yeah, e-bikes, I remember when I was using my e-bike, I wasn't allowed to charge my e-bike in the hallway in the apartment. So that was 10 years ago. But yeah, people, I think, is very, very concerned about batteries sometimes, but the rate of battery accidents, charging accident, it's really low actually. But yeah, there is a big advertisement, bad advertisement of batteries exploding on the media, I think.
Right.
Last question of this nice conversation today is from Maria. Maria, would you like to ask your last question?
Yes, thank you all for an amazing event. I hope you are not too tired to answer the question. So just very short, I'm really curious, what do you think about the polyvalence of battery cells, or in other words, the ability of a single type of a battery cell to be used in multiple applications, for instance, energy storage systems, heavy duty vehicles, and marines, for instance? Do you see it as an opportunity or rather a problem? Or maybe it's too late to answer this question. I totally understand. So no worries.
To be able to use the same cell for multiple applications is simple. So it helps drive the simplicity of manufacturing and ultimately achieving scale quickly. I think the negative is that there's very much a horses for courses situation, and you could have more, get more value out of differentiated products for specific applications. That would be my view.
Thank you.
I think the interesting thing, I'm just reflecting on your question actually, Mary, is that and again, this is more a question also to anybody else who may have a better kind of view of this than I have, is that one of the issues seems to be, and it may be a misconception, is that battery life is a problem. And there's a big impact on, if you sell a car after a few years, that the charging capacity of that car is in decay, and therefore most people are thinking more about, batteries are going to run out of charging capability before I get full use of the vehicle. Therefore, second life or reusing battery cells for other applications like home storage and other things like that doesn't get discussed a lot, because of the media focus on, you're gonna have a car which actually is going to get, is going to run out of charging capability. So I think, again, my understanding, and I'd be willing to definitely learn from anybody else who's got more insight on this, is, most of our battery charging capabilities can outlive the vehicle. So there are a lot of applications where we can use batteries for other storage purposes after the useful life of the vehicle. But the misconception is it's the other way around, which seems to be driving all sorts of other behaviors around people not wanting to own a second generation battery vehicle, for example. So again, open question. If anybody's got any insights on that, I'd be very interested.
Thank you.
Maybe I can share here a quick thought on battery integration. Definitely the key on the aspect that you mentioned.
Yeah.
That cell are definitely relevant, but integration in that case, in the aspect of the usage of the battery, so that's also key. Thank you.
Thank you.
Okay, I think I will announce the end of the session, and I would love to thank you again to our panelists today, Jennifer Channell, Rob Johnson, and Aaron Wade. Thank you very much for participating today to this event. with your knowledge and sharing your expertise with us. And thanks everyone in the audience for the questions, and thanks for the Battery MBA participants making this Q&A session really interesting and lively. We look forward to continue these important conversations together in the office hours and in the coming sessions, although Battery MBA will be finishing soon, this cohort 11. But I wish you a great day, great evening, great morning, great afternoon, wherever you are, and take care of yourselves, and see you next time. Bye.
Thank you.
And hopefully see you all at the graduation on Saturday.
Thank
Will be a nice celebration. Thanks, everyone.
Thanks.
Thank you.
Thank you.
Thank you.
Bye-bye.
Bye.